I'm going to show you a photograph now. This is actually a time lapse made out of about 600 photographs. So I mentioned High Force Waterfall earlier. This was a time lapse I shot in October a few years ago of the waterfall over something like 3 hours, something like 600 images over 3 hours. And then I put them all together into a video. The reason I'm showing you this is because there's the Milky Way there, and there's the Summer Triangle, if you've heard of that, which is a big feature in the night sky. But look how quickly it moves over a few hours. The whole of the night sky, that, of course, is the rotation of the Earth. So something as vast as the Milky Way, it's 100,000 light years across our galaxy, is moving that quickly across our skies over a few hours. So when we run events at the waterfall, we know in August, September, and early on in October, the Milky Way is going to line up with the waterfall. But later in the night, especially when it gets to October and then November, it's not there for long. It goes behind the trees. We have another place we can look from. So we have to adjust on a long winter's night that could be 5, 6, 7 operational hours down there, what we're telling people about and what they can see when they get down there. It's that different. So that's the Milky Way, and that's towards the southwest. The waterfall is pretty much exactly southwest. This is Killip Wheel, another landmark nearby. This is a water wheel on a lead mine on the border between County Durham and Cumbria. And this is another time lapse, but this is looking north. And look what happens. It's over 3 hours again when you look north in the night sky. All the things streaking over the top are satellites, by the way. And in the early part of the night in the winter months, you get lots of satellites. But notice, I'm going to play that again. There's one star stays still. Can you see it? It's reasonably bright. It's by no means the brightest star in the sky. It's nowhere near, actually. It's something like the 60th brightest. Right there. That's Polaris, the pole star, the North Star. It's the closest thing we have to the celestial North Pole. And from our perspective, it's more or less still over the entire night. But everything else goes round and round. So what happens if you join these photos together differently so you can see all of them? I'm going to show you. You might have seen these kind of photographs before. You get trails. You can see the trails building up over 3 hours. So that's another way of showing the motion of the stars. And if you want to take a photograph like this and you want nice tight circles, you must have north or celestial north at some point, Polaris, in your image. If you don't, you're not going to get that. You're going to get really broad arcs, especially if you look further south. So this is something like about 600 13-second exposures with a few removed. The wheel is lit up by car headlights. So there are enough car headlights sweeping around the road over 3 hours to give it just enough light. But any one where there was something like a satellite or a plane going over, especially a plane that was getting in the way for this still image, I removed it. Which is, you have the luxury of doing that when you shoot 13 seconds at a time. Some people shoot continuously for hours, and that's a bad idea, because if you knock your tripod or something goes past you or through the sky that you don't want, you're stuck with it. And there's a still photograph. I've noted your question, John. We're going to come to that later. So that's how you can combine all these together to make one image, a wheel in the sky and a wheel on the land.